Hi, I'm Tim Berglund, and this is DataStax Enterprise Search Queries. The standard way to issue a search query in DataStax Enterprise Search is to issue a regular CQL query, a select query, with the Solar Query column set to a search expression. Let's look at an example. Here we're looking for movies whose titles match the phrase Lord of the Rings. Now we say phrase because that is words inside of double quotes. We do that with a select title from videos where Solar Query equals title colon Lord of the Rings with Lord of the Rings in double quotes. What that's going to do is return the results as CQL rows ordered based on the relevancy score of the query that search has determined. So this is a pretty cool integration between DataStax Enterprise Search and the regular CQL query mechanism. And let's be a little bit more rigorous about the components of that query that we just did. First of all, this expression, field colon term. So the field is one of the fields defined in our Solar schema that probably comes from a column in the Cassandra table, and the term, of course, is the values we'd like to match. Now, the equivalent of a wildcard is star colon star. If that's we want all the documents in a core, that's all the fields matching any values. That'll be everything. A few quick examples. You see select star from videos where Solar Query equals title colon tombstone. You're likely to find at least one amazing movie coming out of that query. Select star from videos where Solar Query equals genres colon comedy. So that could be quite a few results coming back from that. For as many videos as are in that table, we'll get all the comedies out of it. And we might also search by rating. Any that have the MPAA rating of G will be returned by that last query. Now you're limited to 10 results by default, so it's not like you're going to get a lot of data back, but search still has to calculate relevancy. It has to calculate which 10 movies are the most relevant, considering all of the movies. And so it is going to have to query all of the data. And so that would be an example of, I think it's safe to say, an anti-pattern in using search to actually run that query. A search phrase is, again, text between double quotes. So this is if we've got a few words whose order matters, such as pulp and fiction. We want pulp to be first and fiction to be second. We want them together. We don't want anything in between them. Then we enclose those in double quotes and we make that the title, and easily enough, we'll find the film Pulp Fiction out of that query. And this is all well and good based on a single field at a time and a single value. And honestly, that's a pretty useful feature by itself. But of course, we can get more sophisticated with our searches. We have Boolean operators. This allows us to combine terms in arbitrary ways, anding and oring and inverting them as we see fit. We can even group them with parentheses to get a little bit more control. Now these are the supported Boolean operators. We've got and, or, required, prohibit, and not, with the symbols that you see on that right-hand column. These will be a lot more clear with some examples, so let's talk through just a few of those. And or behave pretty much as you'd expect. So if you want to search on title where it contains pulp and fiction, well, then you're going to get one movie, at least in our movie database, and that's Pulp Fiction. If you're going to search on title where it contains pulp or fiction, then from our movie database, you'll get two. You'll get Pulp Fiction and Stranger Than Fiction. Doesn't contain pulp, but does contain fiction. Apparently there are no other movies with the word pulp in them in our sample data, which is something worth looking into. The require operator, which we indicate with just the plus character at the beginning of a term or a phrase, means that that phrase or term has to be in the document regardless of what the other Boolean conditions would have indicated. So in our example here, where we're selecting title and genres from videos, and the query is genres, and then we have a group, adventure, comedy, require the phrase science fiction, the space delimited terms inside that group, there's an implied or. So you can see in the results, all of them are science fiction and have some other combination of adventure and comedy. Prohibit is like require. It's a single character, a minus sign that we put at the beginning of a term or a phrase. And what it does is it makes sure that documents that match that clause will not appear in the results, regardless of what the rest of the Boolean expression might indicate. So in our example, we're looking for title containing Batman or Robin. Again, in parentheses, the terms delimited by a space, there's an implied or, except we're saying, actually, we just mean Batman. If Robin is in there, forget it. We don't want that. And so what you see is you see Batman Returns, Batman, Batman Forever. You don't see Batman and Robin. Not is similar to prohibit. You're probably more likely to see not preceding a group of things, so you're able to negate the whole group, but you're going to do the same thing. Basically, documents that match the following term will not be in the results. You're making sure that those things are excluded. So if you'll notice here, all of the results are comedies. None of them is a romance because we explicitly say not romance. Grouping is where we enclose multiple terms within parentheses. This is like a little subquery or just a logical grouping of terms. They can be chained together with other groups using Boolean operators to make a richer query. And as we saw just a couple of examples ago, when we put multiple terms simply delimited by spaces inside a group, the default operator is or. Now, if you don't want that, if you want and, then you need to be explicit and say and. You can change that default in your Solar Core config if you'd like. Of course, we're not limited to searching just a single field at a time. We can combine terms in one query. By default, again, the OR operator is used to combine multiple fields if we don't specify otherwise. So here, we're looking for any movie that matches the action genre and has an average rating of 5. And you see in the results, those Boolean conditions have held. For example, The Lonely Villa is the action genre, and it's a rating of 5. The Kid Brother has a rating of 5, but is only a drama. It's not an action, but that's okay. There's an implied or there. And Flash Gordon at the bottom, a perennially unappreciated film, is action with a criminally underrated rating of 3.6. Timestamps are expressed in a query in good old ISO 8601 format. The time zone is mandatorily UTC. So you always have that Z on the end, which in ISO 8601 dates means Greenwich Mean Time or UTC or the meridian time zone. The millisecond portion of the timestamp is optional. Now, as you can see here in our data model, we've encoded the time as being basically the first instant of the day. You see the time is 000000. So this is our way of saying that the release date is October 27th, 2013, and we get, of course, the film Frozen.